All right. Welcome back. Welcome back to the stream. Hope you're having a wonderful day so far. Today is Friday. It is a happy Friday, March the 14th, 2025, 3/14/25. Feeling good today. We are going to be diving back into our personal studies and reading some of our books and then doing potentially maybe a leak code problem and then diving in back where we are going to debug some of our small business manager project and fine tune it and get it to kind of working. All right. Hello, Wing Hong. Welcome. Appreciate you for joining me here. How goes it? You did beat Mahan today. Congratulations to you. I've been pushing this off, but I've been pushing this book off, you guys. I've been slacking. I'm not gonna lie. I have been slacking and I need to do better, but dang, I just been avoiding this one. This book is just a little bit more difficult to read. What's crazy, Oskov? How's it going? Welcome. All right, let's get this show on the road. Let me go ahead and let me think here. Hold on. Thinking about work real quick, making sure I have everything put away before I hold on. I'm getting some thoughts about work. Um, yeah, we're all good. Yeah, okay. Sorry. Hello, Tim. Welcome. Sorry, I was thinking about work. Sometimes I have to remember if I put things away or sealed tanks or put the temperature in the right condition or whatnot. So sometimes I get some like panic thoughts. I'm like, oh, did I do that? And anyways, that was one of them. So I had to remind myself that I did do that. Let me go ahead and grab a tissue really quick. I'm kind of still recovering from a cold. Don't want to be sniffling all stream. And then I'm gonna fill up my water bottle. So give me no 1 minute, guys. Just be right back. Stay here with me. I appreciate you guys for joining me. Tim, welcome in. Me at the airport. If I try to remember, I turn off the stove. Any explosions? Yeah, exactly that feeling, right? All right, be right back. Oh, I didn't grab a tissue. I gotta grab a tissue. I know, get a job, right? Gotta get to work. Get a job, Mike. All right, we're back. Sorry, guys. I had to grab myself a little tissue. And we're still recovering from a little cold. If you let me know if you guys are getting that bug that's been going around. People at my work been passing stuff around. There's a cold bug going around lately. Hey, Magnet, what's going on? Appreciate you for joining me here. Welcome back. You guys are here. Leave a thumbs up for the early crew. You guys are one of the regulars here. Drop a thumbs up on the stream. Ryan, welcome back, dude. Welcome. How's your CS50 going? Are you still doing X and P? Let me know if you what weeks you're on. Sorry, guys. Still recovering from this cold, and so by talking, I'm gonna it's just gonna happen because I is what happens when I have to talk here. So thank you guys for bearing with me. Okay, so I'm gonna be honest, you guys. This chapter is kicking my buns. It's so dense. It's there's a lot going on. There's so much information. I've already taken 100 lines of notes here, just of definitions and various things. Like it's a lot so far, and I really am kind of struggling to muster up the energy to continue on this chapter. I mean, I don't want to like skip and come back to hash, but because they're so important. But this chapter is really just draining my spirits. What do you guys think? I'm really enjoying the Fluent Python reading that we've been doing though, which has been fun. Um, so what do you guys suggest? What do you guys think? Should we should we muster up the power to read at least a couple of pages here and then move on to Fluent Python, and then we'll try Leet code and then do the project? And then we'll call it from there for a Friday. Let me know what you guys think about that. Hey, Blitz and Kill, welcome. Good evening. The grind continues. Yes, sir. The grind will go on. Thanks for joining me here. What you been working on? What are you grinding on? Pause. I'm a senior software engineer. You are learning things I didn't even know. Wow. That's awesome. Crazy. Thank you so much for the positive feedback. Do you have any other, feedback or suggestions? If you've been watching the stream here for a little bit, I really try to provide like authenticity with my learning here, and demonstrate everything that I'm trying to absorb, with you guys, alongside you guys. So thank you so much, Blitz and Kill. Appreciate you for joining me here. Awesome, man. I didn't mean to just also tip my hat to you, but I guess that worked. God, that's cringe, man. Jeez, I need to chill. Gosh, that's bad. Okay. We need to prove that we can do hard things, guys. We got to keep going on. We can do hard things. Pause. Gosh, man, a lot of pauses so far. This is tough. We can do difficult things. We can do it. So where did we leave off on last time? Open addressing, double hashing, quadratic probing. I think we talked about that. Quadratic probing, double hashing. Okay, here. So let's do a little review. So open addressing, a way to handle collisions in a table where instead of storing multiple values in the same bucket, okay, so instead of storing values in the same bucket via chaining or in some sort of array, we would rehash the number basically, um, by some factor until it finds an open available bucket. Now you have to also keep in mind that you have to, if you search for an item and it's not that item, it's occupied by a different item, you have to follow that same sequence to get to that pathway. It's like kind of like a treasure map. So linear probing, if you try and insert item kv with hash code of j, where j is equal to k index of k, h of index of the hash of k, right, for the key, j is the hash code, and that bucket is already occupied, then we try to insert the item at array of j plus 1 modulo n, right? So you increase the hash code by 1, modulo it by n, and store it at the remainder of that value. So it basically will just be the next bucket in line almost. If that is also occupied, continue increasing the numerical addition for each attempt. Cons. Contiguous clustering, right? Because it kind of mimics like a contiguous rehashing event, you kind of tend to get items into clusters, right? So that's what's going on here. And then quadratic probing, if trying to insert item key value with a hash code of j, where j is equal to the hash of k, and that bucket is already occupied, then we try to insert the item at j of 1 squared, right? If that bucket is already occupied, continue increasing the numerical addition, right? So you continue increasing the value here. So I'll say, yeah. I mean, you could say 1 plus like B, right? Where B is 0 and then continues on for every index forward, for every rehash, for a better or maybe representation. Okay, double hashing. So this one was just a little bit different because you now have a quadratic being applied to it, so you don't have necessarily that clustering happen right next to each other. But you do have secondary clustering. So secondary clustering where sets of filled array cells still has a non-uniform pattern. Where sets of filled array cells still has a non-uniform pattern, even if we assume that the original hash codes are distributed uniformly. When the number of buckets is prime and the bucket size of the bucket array is less than half full, the quadratic probing strategy is guaranteed to find an empty slot. So when you have a prime, so it's pretty efficient for a half full bucket and a prime number of buckets. However, this guarantee is not valid once the table becomes at least half full or if n is not chosen as a prime number. We explored the cause of this type of clustering in exercise C1036. So we'll put cons here. We'll do 1 secondary clustering, right? And then I'll have to look up a little bit better of a definition than they gave me here. It's pretty vague. But then I'll kind of add here as well onto quadratic probing another note that says if n is prime, right? So n number of buckets in the hash map, right? Is prime. Hold on. If the number of buckets in the hash map is prime, and the map is less than half full, you are guaranteed to find a, what did it say? If n is prime and the bucket array is less than half full, the quadratic probing strategy is guaranteed to find an empty slot. Okay, so I should have just copied that. Woo! Sheesh, it's cold. I'm coming on the other side of it though, so we're feeling better. You're guaranteed to find an empty slot. All right. Hello, Mahan. Welcome in. Welcome back, dude. Hello. What you been working on? Mahan was at uni because of last term tennis plus hanging out with friends after. Nice. Gotta hang out with those bros. Okay. So we'll need to fill in something for secondary clustering here. Double hashing. An open addressing strategy that does not cause clustering of any kind produced by linear probing of the kind produced by linear probing or the kind produced by quadratic probing is the double hashing strategy. In this approach, we choose a secondary hash function h prime, okay, a secondary hash function right, h, oh, is it this prime? No, because that's comma. Tilde is not it either. Right, so it's, I don't know, it's gotta be apostrophe. I don't know, anybody know the hotkey for prime? Right, and if h maps to some key k to a bucket that is already occupied, we iteratively try the buckets h of k, so that hash code, plus function of I, where function of I is I times h prime of k. So you have the hash code times some iteration. In this scheme, the second hash function is not allowed to evaluate to 0. A common choice is h prime of k equals q minus k mod q for some prime number q less than n, the number of buckets. Also, n should be prime. So q is just some constant chosen that's prime and less than the number of buckets. K is the key value modulated by q. You subtract that from q. Interesting. This is a whole language in itself. Jeez Louise. Another approach to avoid clustering with open addressing is to iteratively try buckets. A array index hash of k plus f of I modulo n, where f of I is based on a pseudo-random number generator providing a repeatable but somewhat arbitrary sequence of subsequent probes that depends upon bits of the original hash code. This is the approach currently used by Python's dictionary class. Huh. This is a lot. Let me take this bad boy. We got some tools we can use. So let me take this. Let's go. Can you break this down, please? I understand that if the original hash code produced to index the element into the array is occupied, then we will modify the original hash code by some new hash function h prime. Yeah, let's break it down step by step. Okay, didn't like my explanation. Thanks a lot. You have a hash table with size n. You want to insert a key into the table. The hash function, h of k, gives you the index where the key should go. But if that spot is already taken, a collision, you need a strategy to find the next available spot. Open addressing. Instead of using separate chaining like linked lists at each index, open addressing means you've resolved collisions by finding a new open spot within the array itself. Right? Problem with linear and quadratic probing. In linear probing, you try the next slot plus 1, causing a primary cluster's keys to start bunching up. Quadratic probing, you try slots based on quadratic formula, causes secondary clustering. Keys using the same quadratic pattern bunch up. So you get kind of bunches in small groups. Okay. Whoa, chill. Mike, bruh. Cool. Hey Muna, welcome in. How's it going? Welcome back. Appreciate you for joining me again. I was looking at my state's flagship university ACS curriculum. I'm surprised there wasn't more math required. It's only up to Calc 2 plus discrete math. Some of my tracks do require linear algebra, though. Is further math really not needed? Honestly, that's kind of sounds what the normal CS curriculum sounds. I've never, obviously, not a CS major, but when I was looking into post-bac programs, those were the math classes that were required, um, up to like, Calc 2 and then discrete math. Honestly, some of them only required Calc 1 at some institutions and then discrete math. Um, but I think it'd be useful for us to dive into math just in general, just to give us some general. I mean, think like look at these functions. Like we just having a better overall math knowledge would just make us more fluent in understanding this, these functions and the math going on behind hashing and behind these algorithms. So yeah, it might be somewhat a little bit more basic than calculus or linear algebra, but it just having even a more knowledge and more familiarity in math in general will help us greatly, especially now that I'm out of school and a little bit out of the haven't taken a math class in quite a while. So yeah. Okay. So double hashing, the better solution. So this is secondary clustering. Um, keys that exhibit that share a similar um, what is a polynomial? Is that what it said? Based on a quadratic formula. Share a similar quadratic pattern will bunch up, causing small clusters um, scattered, right? Yeah, right. So double hashing, the better solution. Instead of just adding 1 plus or I plus I squared, you introduce a secondary hash function h prime of k to mix things up and avoid clustering. First hash gives you h of k. If h of k is occupied, try array index h of k plus I times the h prime hash function, modulo by the number of buckets, where I is the number of attempts, h prime is the secondary hash function, and h prime of k needs to be non-zero so you don't get stuck retrying the same spot, because if you multiply by a zero here, you're trying the same spot over and over and over again. Huh. Why h prime equals q? So why this function for the h prime? Q, some prime number smaller than n, the number of buckets, makes sure that h sub prime is not zero and provides good spread of values. Prime numbers reduce the chance of repeating patterns, helping avoid clustering, right? Because they're only divisible by themselves and 1, there are no other factors that go into the q value besides itself and 1, so you'll have not that many collisions on q if you use a prime number. Python's dictionary strategy. Instead of double hashing, Python uses pseudo-random probing. After the first hash, it uses a predictable but randomized sequence based on the bits of the key. After the first hash, it uses a predictable but randomized sequence based on the bits of the key. Keeps the distribution of the keys balanced but also repeatable, so the same keys always probes the same way. Okay. So I'm going to take this. I like this. This is good. Right. Where where I equals the number of temps, H prime of K equals the secondary hash solution, H prime of K needs to be non-zero. Just gonna try to select in the same spot. Right, so let's go Shift Command V and see what that looks like. Okay, so I didn't like this formula, so H of K plus I times, no, H, this guy here, prime of K modulo N. Right, like so. I'm gonna take this, put this here. And then do I have this guy here? So instead of just adding 1 plus, you introduce a secondary hash function, h prime of k, to mix things up and avoid clustering. First hash gives you this, h of k. If h of k is occupied, try this, where I equals the number h prime of k, secondary hash function, h prime of k needs to be non-zero. So a common, we'll go here and say, so let's make these bullets rather than, right? So we'll come back here and say a common h prime of k function, right, is going to be this here, h prime of k equals to q minus k mod q. Right? And then we say q is equal to some prime number less than n, the number of buckets in the array. Right? We have this makes sure that this guy, right, is not 0. And provides a good spread of values. And then here, prime numbers reduce the chance of repeating patterns, helping avoid collisions. Prime numbers reduce the chances of repeating patterns, helping avoid clustering. All right, a couple chats here. That's a bit surprising to me. I guess I was just looking mainly at more math-focused parts of CS. I'm sure you can definitely dive deeper if you so please. They'll take your money for sure wherever you'll give it. Hey, Don Soap, welcome back in. Appreciate you for coming in again. How's it going, you guys? What you guys studying this evening? Let me know what you guys are working on. Okay, let's go ahead and shift focus. That's been a lot of focus here on this so far. Um, we got that's just, I mean, we only read like, we finished one page, but it was just so, see what I'm talking about, like, you guys, is one page, like half of a page. We read this right here, right? Secondary clustering down, and it took us a good chunk of notes here, like 30 minutes now. I'm not super fast and I was reading chats sometimes, but it's just so, crazy here. Yeah, so this is data structures and algorithms in Python. We're currently on page 420, 10.2.3, load factors, rehashing, and efficiency. And we have been reading this book live on stream, word for word, example by example. I have notes here where we do practice problems at the end of every chapter. And if you guys want access to these and get access to some of the practice problems on your own, you can go ahead, and my key solutions that I have, like, as you guys can see, they're pretty detailed with solutions and examples. You can go ahead and this is what my practice came from. Like, I wrote a lot of these functions, like solving these answers, and it's really helped in the terms of the Leet code, right? I'm doing for k and range of, right? I'm having to use these book examples here and the reading to do these kind of functions. Now, these aren't super complete in some cases, right? Just because of, like, um, I think they don't have like all of the implemented things like capacity. Like, sometimes they're supposed to be within classes and whatnot, but they're kind of just dummy functions, really. But they just really help me understand the structure of these, and that's why I'm not that great at the Leet code stuff. I'm only doing easies, but I'm able to get a couple of these solutions on my own here so far, just because of this raw, practice going through all of these. So you guys can get access to all of these solutions on my GitHub. I share everything with you guys completely, and in my Discord for free. Um, when did you start? Hey, Lily, I appreciate you for joining me here. Yeah, for those that don't know, I have a degree in human biology, and a minor in chemistry. I graduated in 2021. I got a job as a formulation chemist right out of college, and I've been working for that biotech company ever since. And I've been teaching myself how to code for little about 7 to 8 months now. I started doing everyday studying and streams about 3 or 4 months ago, around November. Well, now it's actually been end of November, so beginning of December, so about 4 or 5 months now coming up. It's time flying here, in terms of the studying, but it's we've really been grinding away, and yeah, so it's not been too long, but it has been a little bit of time, um, but we got a long ways to go here. You should take Harvard's Intro to Data Science with Python. Yeah, note taking is kind of insane. I personally just read it till I can explain it in my own words and implement an algorithm and leave some comments on the code. That's a good idea too, right? Yes, any way that you can try to like write it in your own words, I think is true. Like, it might be you guys might kind of think it's annoying that I'm kind of rewriting what the GPT spat out me or what the book says, but that's the process of kind of hammering this information home, is that I'm trying my best to solidify it so I don't have to go back and really be confused about previous learning and everything. I'm trying to really solidify it now while I have it here. I'm in no rush, really. So, I mean, a lot of people are in a rush. I feel for them because they're trying to find employment. I'm coming at this from a different field, doing this out of just sheer passion, I guess, and uh, you know, uh, willingness to learn. So I got these like flyaways. They're kind of funny. Sorry. But yeah. Anyways, let's shift focus here to. I want to read some Fluent Python still. We need to keep moving. Um, we don't want to slack on our reading like we did on DSA and Python. We've come really far on DSA and Python, but we're slowing down. As you can see, it's getting really dense. The material's starting to get harder and harder. Pause. But let's go ahead and load up the Fluent Python notes that we got taken, right? Right now we're on chapter 2, right? So here we are on chapter 2. So we left off last time on destructuring. Yeah, right. Pattern matching with sequences, so the atomic values. So yesterday what we talked about was the match case. So we already knew about that. We use the match case a lot with our current programs and stuff. We learned that the stirs, bytes, and byte arrays given as the case will evaluate the entire stir, not not a single value of a stir like it would with you can but you can still unpack them with the star operator. And then compatible with sequence patterns. So if you want to basically create sequence patterns um, to unpack basically into variables or into tuples or whatnot, you can do those with these types of data classes. So destructuring, right, a more advanced form of unpacking by allowing for nested destructuring, right, where you can save these variable tuples into variables, that mimic the current structure of the actual data itself. This should say a wildcard. You can use it as a wildcard um, for extra values. So right, we can absorb all of the middle values 2, 3, and 4 from this variable b, and it'll save it 2, 3, and 4 as a list itself, and then save the value of c as 5 and the value of 1 as a. All right, let's continue on here. Where did we leave off on? It had to have been on a ignoring values. Where did we leave off on? Pattern matching sequences. Okay, so we're on this heading down here. We're here. Okay, let's do like a 15 minutes of reading here, and then we'll move on. How about, yeah? What's in the data science Harvard Python course, Tim? Now that I remember, I'm going to leave a little exercise about data analysis using pandas and Python on your Discord for whoever wants to practice. Yeah, that'd be great. Thanks, Donso. Thank you so much. Yeah. Lots of resources in the Discord, you guys. Feel free to join down in there. The description. Okay, pattern matching sequences in an interpreter. Okay, so Peter Novig of Stanford University wrote list.py, an interpreter for a subset. Okay, so let's do list.py, right? An interpreter for a subset of the scheme dialect of the Lisp programming language in 132 lines of beautiful and readable Python code. What? Wrote list.py. What is this? Open in Safari. Okay. So, an interpreter for a subset of the scheme dialect of the Lisp programming language in 132 lines of code. So, Lisp scheme interpreter in Python 3.3 plus, Peter Norvig 2010 to 2018. Import types. Math, operator as op, collections, chain map as environment. So you define a class procedure. When you initialize it, you have params, body, and environment are its parameters. params body environment equals params body environment. Self dot in environment equals a tuple of all three. Okay. Def call args. So when you call procedure, you run environment equals to. I don't even know what's going on here. All right. Anybody know what that is? Lisp method. For markdown code blocks, if you put the file extension after the first backtick, you get the syntax highlighting. If you put the file extension after the first backtick, you get the syntax highlighting. If I put the file extension, oh, .py like that, so if I backtick that. I'm not sure what you mean. Sorry. Okay. So I took Norvig's MIT licensed course and updated it to Python 3.10 to showcase pattern matching. In this section, we'll compare a key part of Norvig's code, which uses if-elif and unpacking, with a rewrite using match case. The two main functions of Lispy list.py are parse and evaluate. The parser takes scheme parenthesized expressions and returns Python lists. Here are two examples. So parse has a tuple, a string tuple, GCD 18 and 45, and it spits out a string GCD int 18 and 45 in a list. Okay. We parse a call parse on define, double lambda on n, unpack n and 2, or just star n and 2, lambda n. So you're just calling a lambda function within this parse. Oh, so it's going to pull out define, double, and then the function itself in a list. The evaluator takes the lists like these and executes them. The first example is calling GCD function. Is calling a GCD function with 18 and 45 as arguments. When evaluated, it computes the greatest common divisor of the arguments 9. What? The first example is calling a GCD function with 18 and 45 as arguments. When evaluated, it computes the greatest common divisor of the arguments, 9. Okay, so 9 and 18. Oh, greatest common divisor, GCD. Okay, so of 18 and 45, well, that would be 9. Okay. The second example is defining a function named double with a parameter n. The body of the function is the expression star n2. The result of calling a function in scheme is the value of the last expression in its body. Our focus here is destructuring sequences, so I will not explain the evaluator actions. See pattern matching in Lispy, a case study on page 669 to learn more about how Lispy works. Example 211 shows Norvig's evaluator with minor changes, abbreviated to show only sequence patterns. Like backtick pi. So if I just did like that, like that, huh? Interesting. On code blocks between text, On code blocks, text between triple backticks like line 146. Oh, the Dyntax highlighting will be shown on the parsed markdown file. Yeah, I have a block here, like a code block. Is that not how it's supposed to be? Let me know. I do need to make that go in. There we go. It's Friday. You gotta grind away here. Work on your projects. Hey, Victor. Do you know if there's a CS50 course for C? Yeah, CS50X, what we just took, it starts out with C. The first 5 weeks are entirely in C and learning about C. So I highly suggest you watch the videos I've been posting on my channel of the the watch-alongs. I have condensed versions I've uploaded as videos, or you could just go back and also watch the live streams themselves if you want an unfiltered, unedited version with like the chat read-alongs and everything too. Um, so, feel free to use my channel here as a resource to kind of, work alongside as you take the course and hold yourself accountable. We just finished watching the week 10 lecture yesterday, and we're going to be working on our final project. We currently pretty much are. I'm going to be using the small business manager project that we wrote, um, uh, and it'll be pretty nice because I'm going to then convert our current version into a more full stack environment using databases and everything, and it'll be really cool. So stick around for that. Um, if you put the pi, you get the syntax highlighting. So put like backtick, 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 pi. Okay. Just add pi after the 3 backticks. Okay. Pi. Oh, look at that. Oh, look at that. That's cool. So then how do I keep it wrapped here? That's going to do it to that one. I don't want to do it to that one. I want to, because it's still, jeez. You guys feeling the spring cold coming in? Data Alex is still. Oh, it is working for that. Data Alex. Okay, cool. So we got to do it to the one above it then. Here, pi. Nice. Look at that. Thank you so much, Don Soup. Sweet. Look at that. Neat. See, look at these notes, guys. I've really tried my best to give you guys some solid, extract out the really important stuff and provide that to you guys here with, screenshots. It's really, detailed for you guys. So use these notes, just give them a pass through once. I would suggest just give them a read through. It'll take you 15 minutes, like per chapter, maybe, and then come just pick a chapter a day, read through the notes. You don't even have to read through the book because I've really captured the really important stuff here in the notes. And just read through the chapter notes, then come back the next day, read it again, and then, and then come back the next day and then just try to like convey what it was if you remember, and then move on to the next chapter. It also works on Discord. Wow, I didn't know that either. Shoot, man. You learn something every day. All right. We got about 10 more minutes till the top of the hour here on the stream, so let's keep on going here. Appreciate you guys so much for joining me. We've been streaming for 50 minutes so far. What you guys working on? What are you guys studying on the side? Let me know what you guys are working on. Or if you guys are just watching and reading the book with me, let me know that too. I always find it fun if you guys are actually, doing it with me here. Okay. Okay, so here's a function it gives us. Oh, shoot. Did not mean to do that. Come on. Did not mean to click that. There we go. Okay. Our focus here is destructuring sequences. So I will not explain the evaluator actions. See pattern matching in ListB, a case study on page 669 to learn more about how ListB works. Example 2-1 shows Norvig's evaluator with minor changes, abbreviated to show only the sequence patterns. Okay, so this is the example here. Matter, matching patterns without match case. So evaluate. We given an expression and environment, which is a class, expression, and environment. Returns any. Evaluate an expression in an environment. Okay? If instance of the expression is a symbol, return environment index expression. Right? Lines emitted. Elif expression index 0 is equal to quote, right? Save expression as, or unpack expression with the value of x, right? And some, dummy value we don't need, and return the x given. Elif, if that index is if, okay, so got you. Okay, cool. Note how, okay, so we're just using if elifs. Note how each elif clause checks the first item of the list and then unpacks the list, ignoring the first item. The extensive use of unpacking suggests that Norvig is a fan of pattern matching, but he wrote the code originally for Python 2, though it now works with any Python 3. Using match case in Python greater than or equal to 310, we can refactor evaluate as shown in example 2-12. Example 2-12 uses the match case now. So we match expression with this case of quote x, return x. If this is, okay, so you're matching these patterns within this list. So if you have a list that starts with this, you can take these values, save them as these variables, and then basically do something with them, evaluate on these, right? So you're evaluating the expression and then calling the evaluate with that environment then. Okay, got you. Interesting. So in line 1, right here, match if subject is a 2-item sequence starting with quote, right? In line 2, match if subject is a 4-item sequence starting with if, right? So you can match sequence of lists basically kind of like I simplified regular expressions almost, which is variables rather than codes almost. So yeah, match subject in line 3 here. Match subject if subject is a sequence of 3 or more items starting with quote lambda. The guard ensures that body is not empty. So case quote lambda, we wrap and unpack params in a list and save body as is unpacked. If body, return this. And then in line 4, match if subject is 3-item sequence starting with quote define, followed by an instance of symbol, right? It is good practice right here in line 5 to have a catch-all case. In this example, if expression doesn't match any of the patterns, then the expression is malformed and I raise syntax error. Without a catch-all, the whole match case statement doesn't does nothing with when a subject does not match any case, and this can be a silent failure. Norvig deliberately avoided error checking in Lispy to keep his code easy to understand. With pattern matching, we can add more checks and keep it readable. For example, in the defined pattern, the original code does not ensure that name is an instance of the symbol. For example, in the defined pattern of the original code does not ensure that name is an instance of symbol. So um, that would require an if block and an is instance call and more code. Example is shorter and safer than code 211. This is the syntax of lambda in scheme. This is the syntax of lambda in scheme using the syntactic convention that the suffix ... means the element may appear 0 or more times. Okay, so ... does the unpacking. A simple pattern for the lambda case, quote, lambda would be this. Case, quote, lambda parms which is a list, and then a bunch of variables body. If body, do those. However, that matches any value in the parm's position, including the first, quote, x in the invalid subject. Lambda, quote, x, all of those. The nested list after the lambda keyword in the scheme holds the names of the formal patterns for the function, and it must be a list even if it has only one element. It also the nested list after the lambda keyword parms, right? The nested list after the lambda keyword in scheme holds the names of the formal parameters for the function, and it must be a list even if it only has one element. It may also be an empty list if the function takes no parameters, like Python's random.random. In example 212, I made the lambda pattern safer using a nested sequence pattern, right? You catch all, including that x. Got you. Oh, okay. All right, we'll pause there. Actually, we'll finish the page and we'll pause at the end of this section here. How about, yeah? We'll run around it out here. Alt patterns for lambda. This is the syntax of lambda in scheme. Using the syntactic convention that the suffix ... means the element may appear 0 or more times. A simple pattern for the lambda clause, quote, lambda, would be this, where we accept a case where we have an initial sequence of, quote, lambda, which we do here. We capture a tuple, right, of parms in a list called parms. It's not displayed here because you don't need to visually show that this is a list. This is just going to be a variable that houses a list of values. And then body, which is just a bunch of variables, body 1, body 2, as many variables after this. However, that matches any value in the parms position, including the first, quote, x in this invalid subject. So if you give them this, you get this guy as well for the parms, right? The 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 nested list after the lambda keyword and scheme holds the names of the formal parameters of the function, and it must be a list even if it has only one element. It may also, oh, I already read that, didn't I? I already read this. What the heck is going on? I'm tripping. That's interesting. On all other language, case underscore is the default keyword. No, it's yeah, it's the catch-all for um, anything that wasn't given in the other cases, basically. It's just like the catch-all for everything else. Okay. In example 212, I made the lambda safer using. I swear I read this. No? What's going on? Yeah, okay. In example 2-12, I made the lambda pattern safer using a nested sequence pattern. Where case, right? We look for this case. We take parms, which is a list, and then we have body. So we explicitly wrap everything in parms in a list, right? In a sequence pattern, star can only appear once per sequence. Here we have two sequences, the inner and outer. Inner, outer. Adding the characters list star around parms makes the pattern look more like a scheme syntax, look more like the scheme syntax it handles, and gave us the additional structural check. All right. That's going to be enough for reading for today. Let's move on to some other things here. Woohoo! Hey, Victor, welcome. How long does the CS50P course take you? I did it very, very part-time over the course of the summer. I started at the beginning and I finished at the end. So pretty much about 3 months, give or take. I did it very, very part-time though, on and off over the summer as I was still trying to figure out if this was something I wanted to invest a lot of time into. I decided, yes, it is something I'm pretty passionate about after that course, and yeah, then here we are. So we completed that course at the end of summer 2024. All right. Anybody have some problem suggestions for a Leet code for today? Nothing too hard, please. Please, please, please. Oh boy, oh boy, oh boy. What do we got going on here? Yeah. All right. Let's get this on the road. This is one of the only ones we haven't done out of this section. So do we finally have to do the Roman integer? Oh, no. 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 Been avoiding this one. I don't know why. I don't know why. It just looks hard to me. Pause. Okay, Roman numerals are repeated by 7 different symbols: I, V, X, L, C, D, and M. For example, 2 is written as II in Roman numeral. Just 2 ones added together, 12, is written as XII, which is simply X plus II. The number 27 is written as XXVII, which is XX plus V plus II. Roman numerals are usually written largest to smallest from left to right. However, the Roman numeral for 4 is not 4 I's. Instead, the Roman numeral for the number 4 is written as IV. Because the 1 is before the 5, we subtract it, making it 4. The same principles applies to the number 9, which is written as IX. There are 6 instances where the subtraction is used. 4 and 9, 40 and 90, 400 and 900. Oh, 5 and 10 to make 4 and 9, 50 and 100. What? I can be placed before V and X. Yes. Oh, got you. I can be placed before V and X to make 4 and 9. X can be placed before L to make 40 and C to make 90. So you can reduce by 10, and then you can reduce by 100 with C. Okay. You can't put D before M and reduce by 500? Okay. Let's crack the neck. Let's see what we can do here. And you guys solve this one? All right. So, right off the bat, we can map this to a dictionary, right? So, nums is equal. We're given a string. What are we given? An input of. Oh, we're given the Roman numeral. Oh, I thought we were given the number. Oh. Hmm. I thought we were given the number. Okay, that changes my thinking then. We're given the Roman numeral in a string. I did not see that coming. Okay, so we're given the Roman numeral in a string, and we need to output the number associated with that value. So we basically need to have a counter saved. Right, so counter equals 0. We need to loop over every value in every numeral in the Roman numeral. For numeral in Roman numeral. For we'll say char in S, right? For Roman and Roman numeral. For every Roman numeral. So for every character in the string, right? We still need our map though, right? Because we still need to associate those characters. So let's make our map is equal to a dictionary where we'll have basically this here. Right? It's probably made it way more difficult than it needed to be. Okay, we're gonna have to just, this is, yeah, I'm not gonna do that. Right. So we have 1, 2, 3, 4, 5, 6, 7. We have V, we have X, we have L, we have C, and we have D, and we have M. M is 1,000, D is 500, 100 for this guy, 50 for this guy, 10 for this guy, and 5 for this guy. Michael's falling into insanity, laughing at a Leet code problem. That's how you know I'm in too deep here, boys. I'm finding Leet code humorous. Oh my gosh. Don Soap keeping me in check here. Appreciate you. Okay, so we have a map here of all the values and the keys associated as such. These need to be commas, not semicolons, right? Um, so for character in S, right? I can't become before V. X can't become before L and C. So do we really have to use a bunch of elif statements to like handle all these edge cases? Okay, so let's just add it. Let's just do the incorrect version. Let's just make it, and then we'll do the edge cases, right? So for every character in S, um, if char in map, right? If the char is in the map, we are going to get value is equal to counter plus equal to map dot get char, right? So that'll get the value of char right off the jump. So that'll be incorrect for just a few of these cases, right? It'll work for that one, counter plus equal, and then at the end of the loop, we will return counter. So let's just solve it for just this case one here. Yeah, there we go. So now we need to focus on these edge cases. Okay, so right here where you have the subtraction taking place. So, crap. We need another pointer here then, right? We have to evaluate the next character. Oh, come on. Okay, so for I in range of n, we'll make n be the length of the string given if the string index I, right, is in map that, and then we'll get string index I. So we'll just make sure now it's working for our new changes here. No. Bingo. Okay, so now we're back to where we were. So that's cool. That's cool. This is a fun one since you just started. I don't help. Struggle a little more. You, you for sure get it. Yeah, we got this one, I think. Okay, so now let's go ahead and see here. We need to evaluate a second pointer. So this is for I in the range of n. So minus 1 and then for j in range I plus 1 to n, right? So if our first thing we need to evaluate, right, is if the left pointer is an I and the right pointer is a V or an X. So if the left pointer is I, X, or C, okay, so this is what we got to do. If string index I, the left pointer, the left gun, if the left gun is on either in, if the left gun is either bang, I, oop, bang X or bang C if it's in this tuple and S index J in this tuple of either Vx LC I don't know, this is getting kind of redundant here, and D, are we doing things right? An M, right? If it's in those, we're going to take the value of S index J plus equals the value of map dot get S index J minus map dot get I guess we don't even need to do dot get, right? We just need to index into there. I'm not sure why I'm using dot get. I don't need a default to fall back on. This might be a little bit cleaner to see, but we can index, no problem, into this, right? So get rid of that. So we reduce map by, we go J, the left pointer, minus the value minus the value of the right, we take the right pointer, the bigger one, bang, and we minus the value of the left pointer, bang, right? So we take V and reduce it by this. So if S index I is in this and S index J is in this at this point in stage, we reduce. If that's not the case, else just do this. And return counter at the end of the loop. I mean, we don't even need to use get here again, right? Like so. I don't know. I'm afraid to submit. Let's think about this. What do you guys think? Am I failing? Okay, so we have a left pointer and a right pointer. Let's take our example here, case 3, right? Let's take this example here. Left pointer is on M, right pointer is on C. Okay? We know from our conditions that, okay, none of our conditions is met, so we take the value of M and we add it. 1,000. Okay? Boom. Okay? We then go, we have C, okay? But C comes before M in this case, which will be caught by here. So we take the value of M, which is 1,000, minus the value of C, which is 100. So we add 900 to this value. Boom. Mahan says, why don't you loop from the end? It's an interesting point. If you loop from the end, do you just add from the end? Let's see here. So you add V. V is, honestly, I don't really know how I'm not too familiar with Roman numerals. Like I just use them for the Super Bowl. So that's probably why. I just don't have enough practice with them in general and counting with them. So V, so that would add 5. I would add, oh, do you just subtract and then take the absolute value? Oh, man. No. Let me see here. 1 minus 1 minus 1, negative 3. -1 minus 1 minus 5, negative 3, negative 8, minus 50. This would be negative 4, negative 5, negative 6, negative 106, negative. Hold on, let me add this. Let me go calculator. Okay, so where did I go? Come back. Okay, so what if we go V? Let's go up to here. So V is 5. Let's take 5 plus, or no, 5 minus 1 minus C is 100 minus X, which is 10, minus M, which is 1,000, minus C, which is 100, minus another M, which is 1,000. 2206. So that okay, no. So that strategy does not work, unfortunately. So what do we got going wrong on here? So for I in the range of left pointer and right pointer, if S index I is in this tuple and S index J is in this tuple, we're going to add to our counter the value of S index J plus minus S index I. So then if we don't get that, we just increase the counter by map at the left pointer. Huh. It's not even working for this basic one either. Why did I get 218 here? Let's think. 218. L is 50. V is 5. And then 3 eighths. So L, so it wouldn't have gotten in that one. But S index J is at 1 greater, so it is in there. So it's doing this. So it's doing. Okay, so it's doing the L minus V minus L, 5 minus 50. Negative 45. What? Huh. I wish I could debug this. Use the debugger. I want to see what's happening at every loop here. Should we copy it into our Python here? Also, why not adding all when you just see the... why not adding all? Figure you just subtract. You just subtract. You don't do that in all cases though, I don't think, right? Where 6 instances where subtraction is used. So can you take 1 away from the L and make 49? 2? It's not given in one of these 6 conditions. All right, let's take this to the VS Code. Let's Let's make a Nico practice. Let's do what's it called this? What's this one called? Number 13, Roman. 13 dot pi. Let's debug this one. Okay, let's bring it back. Let's print the counter here at every loop. So we'll print counter at every loop here. And then we'll print at the very end. How about 2? This is fun. We're debugging. Okay, where should we throw our... We gotta give a string, right? Oh, shoot. Let's give a string. Let's take this one. We'll start with this guy. We'll do the other one, the harder one in a second. All right. Let's see here. All right. Let's set our breakpoint on the print. And then let's run debug mode. Debug. Okay, so we gotta, okay, here we go. These are our variables. Here's our map. Let's go, let's play. No. Shoot. Okay, here we go, over here. We want, oh no, that's where we're starting. I don't want to do that. Let's start, let's start here, right? All right, we never do this, guys. This is fun. Okay, so we want to step into the for loop with this guy, step over, step into. Okay, we stepped in. I is 0. We haven't established j yet until after we move past this for loop, but we have n is equal to 5. Okay, perfect. We move forward. We establish a j at index 1. Perfect. Okay. Boom. We evaluate to this on our first instance. So counter goes up by 50. Perfect. By the L. Okay. Nice. Now let's keep going. Okay. So we're back in our J. Oh. No. That's what's happening. No. Ah. Interesting. Okay, so our I is not increasing. That's right. Because we're stuck in this loop here. So we gotta break. Or we could just say while j is equal to I greater than 1. Right, we could just say this. J is equal to I plus 1 while j is less than n. No, because this will do the same thing. So if j becomes, okay, we'll do this. We'll do this. If j is equal to n, turn crazy for doing that? Oh, I am crazy. I'm getting old. So we establish J plus, I'm just kind of having fun here, trying new stuff. So if we say J is plus one greater than I currently, if we get J is equal to N, return counter. Okay, so that we gotta remove that then. No, we're one short. One short. That one didn't work. That didn't work for sure. Dang it. Dang it. The 4 is happening, right? That's working. Oh, but if you add, right, this resembles 4. This is not 1. This is not 1. Oh. This is not what it's doing is then it's adding the 5. Right? It's saying, okay, but no, it's stopping there. But here, what it's doing is it's okay, saying, oh, the C comes before the M here. Let's go ahead and do that subtraction of, C 100 minus M 1000, so 900. But then it's moving to the M and adding the 1000 when it should just be moving directly to the X because the CM is a Roman numeral character. Nah, Mahan, I'm alright. I'm cooking right now. I'm chill. Um, so we need to basically, rather than do a for loop to make I go forward no matter what, we need to do a while loop. And then if you do one of these cases, right, if you meet here, you increase I by 2. Okay, let's try that. So you have counter, length n for I. No, we're not going to do that. We're going to do while I, we're going to say I is equal to 0. While I is less than n, right? We're going to continually we're going to make j equal to 1 greater than I. If j becomes equal to n, we'll return counter right there. If index I is in counter, we're going to then increase I plus equal plus by 2 and then move that bad boy forward, else do that. Let's try that. Bah, 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 uh. Come on. No. We got an infinite loop, so we're not breaking. Oh, interesting. I'm not breaking somewhere. Let's see here. If this, else that. Okay, we need to increase I by here, by 1 as well. And then, that's fine. Let's run that. And null on that one. Dang it. Hmm. Dang flab. So, in this one, we're 1 short because we're not adding the last value, right? Because we want, if I is equal to n, right? So if I is equal to n, right, we'll return counter. We won't even get to do this because we won't even do this evaluation of 1 greater than j. So that'll solve that for those first two examples, I think. Ow, bye. String index out of range. It's still evaluating that. Oh, because it's an if, so I'll say elif. Dang it. Why is it still going to that? Right, why is it? I should be returning counter if I hit this. Why am I still evaluating this condition here? Interesting. Hmm. So we're increasing I by 2. And then what? Continuing? Why is this getting evaluated? I'm returning once I becomes equal to n. That doesn't make any sense to me. If I return, so I'm setting j, I'm not evaluating j until past this return statement. So if I is equal to n, oh, is it -1? Because that's the last index, so you return on the last index. But I think that we'll still have our problem of being 1 short, right? Is it still returning but going to this statement here? I don't know why that. Hmm. You know you have Vx, right? These are the 6 conditions in which it said subtraction take place, so I'm just using what the problem gave me. Right? It's saying these are the 6 instances in which subtraction takes place. So I'm just going with what it gave me. I thought about what if it's I and M, wouldn't that give me 999? But it didn't say it here for this example, unless it's poorly written here. It only says these are the 6 examples. So why is this giving me 1 short? So it's giving me 1 short because I is not getting up to past the last character evaluating. So if I is equal to n, should we take this to the bugger? Let's take this guy. Let's get rid of that. Here we go. Let's throw it in here. Okay. Let's put our breakpoint here. counter there. All right, and let's just relaunch this. Yes. Okay, so we're in. Okay, our I is 0 and our J is 2. Why is J 2? What? I plus 1. If I is 0, why is J 2? Why? Ain't no way. Stop. Get out of here. Stop. Run and debug. Okay, I is 0. Let's step into this. I is 0. J becomes 1. Okay, here we go. Now we're fine. So J becomes 1. I is 0. Counter is 0 here. Why is it printing counter here? No, I don't think so. So that gives us I is 0, J is 1. Counter becomes 50. J is 2. Counter becomes 55. J is 3. Counter becomes 56. J is 4. Counter becomes 57. We enter this while loop. I is 4, so it's still less than N. J becomes 5. That should be evaluated to true at this point in time. Oh. Wait. So this is running, but it's giving me an error? No. Okay, I thought I was getting an error still. No. Okay. So I'm printing out my I value. One before I do this. So if we're on here, we'll just do this and return then, I guess. So we'll increase counter by map and return counter if you're on the last value, if you so happen to be there. So that should solve number 1 and 2 again, but we're still not solving number 3. We're getting null back, which is interesting. So let's take this string. Let's put it into here. And then let's put we need to put this guy here. Okay, let's stop this. Let's run a debug, see what's going on. This is fun. I like the debugger. It's a good tool. Where's this been all my life? Okay, so we go in 1 and 1, and it's 7 in this case. 1,000. Perfect. Okay. Okay, this is the case where the C is before the M, right? And this is the next iteration here. So we should be adding in 900. Boom, we are. Okay. And I should go up by 2. So I should become 3 here, which it does. 3. So then we keep going. We evaluate, okay, we're inside this one because we are at a case where We're at M and X, right? No, we're at X and C. So X is here. Oh, X and C are in the same column, but C is there too. So this should be adding 90, but I don't think it is. What is this adding? Oh, it is 90. I is 5. J is 6. That adds 4. What? Wait, what? Why is that returning null? Whoa, what's going on here? Um, why are we not returning counter here? Oh, because it. Oh, wait, what? I'm confused. Why? Huh. I'm not returning, literally. I'm literally not returning, right? So it's not getting to this statement. So this statement isn't being evaluated at that point in time because I is 2 less. In that case, okay, because I is 2 less, I see. Dang it. So what can we do to solve that? Oh, what can we do to solve that? What can we do to solve that? On the case where you have if I is, I guess you put it right here, right? If I, now you increase I by 2. Would you do it before or after the increase? So in the CM, you increase by 2, skipping over the M and landing on the X for your I. You add the X, move forward. You're on the C and the I. You're on the C, so you add C, which is 100. You move forward 1. You move, okay, so, or I is equal to N. No, dang it. So you would come, you're on this one. You would add 1 coming up to this I. You would detect, okay, I need to do a subtraction here. I increase I by 2. Oh, so 1 plus N. Maybe? No. What? Am I trolling? Oh my gosh. So if we're on this value for our left pointer and our right pointer is on this one, no subtraction is taking place. If I move forward 1 step to the next loop, I'm here and a subtraction takes place. So I move forward I after the subtraction 1, 2 values. Oh, the loop breaks, and I don't enter this loop. Ah. There we go. Yes! All right, so now let's try it. Hopefully there's no edge cases we missed. I don't know. No! Oh, that's funny. Hold up, my bump my dock here, my bad. Oh, shoot. I can't see, it's too dark. There we go. Sorry, guys. Bumped my dock and it loosened all my stuff. There we go. Okay, so what are we doing here? We're missing this guy. Ooh, D comes before C. So this adds 500, which it's not. What? Why is that not immediately adding 500 on D? It's not in there. The right pointer is, but the left pointer is not in there. Where is it getting? Okay, so we're adding 500. Let's take our thing here. Oh, hold up. Let's take our solution here so far. Come over to our debugger. Boom. Boom. Boom, boom. Okay, we're going to print the counter here. And we're going to print the counter here. This is fun. I'm having fun. I like the debugger. Where's this been all my life? Okay. Put the white loop there. Let's enter this bad boy. All right, so we enter. Let's keep moving. Oh, we don't have the right string in there. Let's take this string. Let's stop that. Run. Okay, let's keep going in. Okay, adds 500 to the counter. We get to C and X, which should not have any subtraction taking place. Ooh, here we go. So C, X can pull from C. Okay. So in this case, right, in this case here, oh, you guys can't see, sorry. Yeah, my thing froze when I hit my dock. It always does that. I'm sorry, guys. There we go. Sorry. Okay, so if we're debugging this. Okay, so I have 500 for my counter. I'm on C and X. So X comes before C, but so no subtraction should be taking place. We should just be adding 100. So this should become 600. No. Step out. Huh. Why did we get triggered there? We had a left pointer on C and a right pointer on X. Oh, you have it here. No. Oh, that throws a wrench in our current approach. That sucks. Oh, that sucks. big time, right? So, and technically, the X and the C are interchangeable here. Dang it. So the left pointer is X. Oh, gosh. All right, so CX is screwing us here, right? Because CX is found in both places. You can do, so we just need to fix that one case, C and X. So if the left pointer is, so if the left pointer is X, if the left pointer is C and the right pointer is X, then we need to just do this. Okay. Match case. So elif S index I equals quote C and S index J is equal to quote X, we're going to do this here. Right. That'll increase I into the next loop. Maybe? No. We've got a V in X case too. So this is XC, CX. This is reducing down by a fact. This is 20 less. So this is 500, 100. So 6, 10, 10, and 1. So this is doing negative 10s. Mahan, I really don't want you to tell me the answers, bro. Like, I want to struggle through this, so please, like, honestly, man. Like, I get that you know it, bro. The whole point of these problems is to struggle through them and find approaches. Okay. So clearly there's too many edge cases on this approach right now, um, that it's probably not the most effective way to go about this. So we should probably rethink, right? All right, I'm fine with that. So let's think then. I mean, I've kind of had a lot of things already spoiled. Wink, wink. Kind of killed my whole vibe, honestly. A little frustrating. But I will try that way. So obviously there's some sort of math sequence you have to do about it, as you guys were alluding to, with if the value is higher, then you subtract something or other. So let's take this example here, or let's go to one of our edge cases. So in this case, we just need to add straight. I'm not sure why it was getting reduced down here. The current method. Obviously, it was getting hit somewhere here. Maybe that on the last one? No, the X. Oh, on the X and the X, we were taking it down by 10. Skipping it forward. Okay. So let's just go back to our first approach, right? For char in, I know I'll say for I in range of n, right? We're going to get the value. So what's the difference? There's obviously a pattern here with the way these numbers are separated. If there's a difference of 1, a difference of a difference of 1, a difference of 10, or a difference of 100 between the left pointer and the right pointer, then subtract them, right? So for I in the range of this, and then the J pointer is 1 higher. For J in the range of N, this looks funny. All right. For J in the range of N, well, this is going to still do that loop. I don't want to do that. No, I'm just going to... I'm kind of blanking on my... So for I in the range of N, so we're going to go 1 less than N. For J in the range... So this, I don't want to do J though, because I'm going to get stuck in the loop, the secondary loop. So what do I want to, how do I make these both go at the same time like I was before? I'm starting to burn out here. My mind's getting slower and slower the longer we go here. We're crossing over the 2 hour mark, so it's how you know we're starting to fade here. I'm good for about 2 hours after work, and then I start needing a break, and then I'll come back for like an after hours. Okay, I'm starting to slow down. I can feel it. While, I guess we'll just say I is equal to 0, while I is less than N, J plus equals to, or J is equal to I plus 1. Let's go ahead and say, kind of our similar setup, I guess, to what we had before, right? Except our condition is going to change here. So I guess we'll say if numbers, no, if stir index, I'm really slowing down. Gosh, my brain is starting to fog bad. While I is greater than n, j is plus equals to 1 greater, if um, string index I dot get um, wait, how do you, what was I calling before? What I gotta call? Um, string dot get, oh, sorry, map dot get string index I. If this value minus, no, if the j pointer minus the map dot get s index I, right? If this value is is um, in this set, this tuple, so if you subtract them and it makes a value of 1, a value of, no, so it can be a value of, sorry. So if you take, I suck at Roman numerals. If you take a 5 minus the 4 minus the 1 and get a 4 or a 9. So you get a 4 or 9. So the right pointer can go down by 1. See, this is why I've been avoiding this problem. I'm terrible with Roman numerals. Um, so the right pointer, so what's the obviously there's a pattern here. 400, 900, 40 and 90, 4 and 9. So he goes factors of 10 every time. So if we subtract the values, so if we have a 1 and a 5 next to each other to make 4, right, in this case here, if we take the 5 minus the 1, that gives us 4. Okay, so if it's in 4, 9, 40, 90, and 400, 900, I mean, it's not super, I mean, I don't know, 40, 90, 400, 900. Is there a way we can use division? Divided by 4. So if it's in this, right, then we're going to counter plus equals to this, right? Huh. Elif I'm starting to fade bad here. I need a little bit of a break. The words are starting to jumble. um, so if it's like you greater than 1 if I goes... Okay, so you still need to skip over twice, though, right? Because you don't want to count the number. So you have to go I plus equals 2. This will be an elif statement because we still have to have the if statement out front to if I is equal to n minus 1, return, we're going to do basically what we had before, right? Let me bring this over here. Bring that over there. Like so. And return counter elif, right? Or else, rather. We're going to do this and increase I. Right? And then at the end of the loop, return counter if you go one beyond. Right, so while I is less than n, while I is less than n, j plus equals to 1. If I is equal to 1 less than n, or the end of the array, or the end of the string, then we're going to take the counter for that value and return the counter. Elif, if we evaluate the left and right pointer subtracting each other, if they result to these cases of 4, 9, 40, 90, 400, or 900 as their value, then we're going to increase the counter by that value. And then increase I by 2 to skip over that value. I think this will work. I'm not sure. Let's find out. Oh, baby, come on. Show me the money. Yes! Nice! That's what I'm talking about, you guys. Woo! See, now isn't that so much more satisfactory that we were able to get that by ourselves here? Like, that's exactly what I'm looking for. That dopamine hit right there. That rush. Endorphins right there. I just got hit with it. Woo! Juiced right now. Nice, we got it, boys. Let's go. I was avoiding this one for a while because I just do not like Roman numerals. For some reason, it's like I get dyslexic with Roman numerals. It's like my kryptonite. I cannot deal with the Roman numerals. Nice. I mean, we were on the right. This was our first attempt, right? We were on the right track. We just had the wrong elif. We had the wrong elif. That's all that was wrong. That was really close for our first attempt, and then our second attempt was spot on. So our first attempt, we just had the wrong elif. That was the only thing that was wrong, was this elif condition. We just had to change this one line. Yeah, woohoo! Nice, feels good. Feels good. Leave a thumbs up in chat for that one. We solved the Roman numerals Leet code problem number 13, Roman to integer. I wonder if there's an integer to Roman. Is there an integer to Roman problem? Let's find out. Mahan, is there an integer to Roman problem? There is. This one's a medium. 7 different symbols represent Roman numerals with different values. This is what I thought it was going to be. This is what I was avoiding. I thought we were going to do the inverse. I was like, oh, I don't want to do that. Roman numerals are formed by appending the conversion to decimal place values to the host line. You'd have to like divide the number in each time. I mean, this one kind of seems pretty similar to, is this one kind of similar to like that change problem that we had in CS50 where we had to compute the remainder change given back? Would we just modulo the number take by some factor? I'm not sure. I'd have to think about it a little bit more. Do some writing down. 3,000 is MMM. Right? Could you take this, divide it by 1,000, and take the remainder every time. So that'd be 3. But here 4 should be IV, right? Right? Because you have 3,000, so this will give you the... Okay, so for 3,000... So you definitely have to work in chunks. Like you have to take the largest factors out first. So you divide by 1,000 if that value is positive. Okay, so what you would do, like, we don't have to solve it. We're not going to solve this one today, but would you take your 3,749, divide this by 1,000, or sorry, you would mod by 1,000 if possible, right? If this is an integer, meaning it's whole, right? Well, this would give you back what? 3.749, right? We would take the 3. This would give you just 749 back. So you take the whole values, then you divide by the 500. That goes in once with 249 left over. That gets multiplied here. So this would be MMM, MMM for 3 M's. This would be 1/500 for a D. We would take the leftover 249, divide modulo this by 100 with get a remainder of 2.49. We would multiply the 2, get 2 100 values, so CC, right? We would take the 49 modulo by 50. This would not give us anything. We would take the 49 modulo by 10. This would give us 4.9. We take the 4, multiply over. This would give us 4 tens, right? So XXX, X. No. See, that's where I messed up. So they do XL for the 4. What? 3,000, 500, 750? No, XL. Whoa, what's going on? Well, let me take this guy and run it into our function here. Hold on. Yeah, so you get 49. You just have to subtract the 49 out, and then that would give you the whole number, right? So you would mod it. You would get back this value, and you just subtract it from this to get back your 500, and then correlate that with the key, right? At each step, you get 249 back. Well, you take 749 minus what you got back from the return. That gives you back 500. You map that to the key value of D. So then what's happening here in this? So you add 1,000, 1,000, 1,000, 500, 600, 700. You XL, which is 40 and 9. Oh, because you have that case of 40. I don't know. Let's give it a go. Let's see what we can do here for 10 minutes. Okay, we're going to loop through the nums. Okay, we're going to take the current value we're on. Oh no, we're going to say for, or we'll just say while true, I guess, or we'll have to think of a better condition, right? So we'll say stir is this, s is equal to this. Let's grab our map from before. Oh, shoot. Let's inverse the map to get the values on one side and the symbols on the other. Quote I 5 10 50 100 500 1000. So this would be I. This is, we're going to map this as V, as X, L, C, D, M. Okay. Okay, so we'll see here. While true, let's go ahead and say this. So take your current number. If num modulo 1,000 so if num modulo, let's see here. Let's open up our other Python. Let's do some testing here. Just open up a blank. Okay. Let's grab a thing here. Woo! Pardon me. Still coming up from that cold, you guys. Woo! I'm getting wrecked here. All right. Ooh. Hey Ryan, what's going on? We're just doing some fun. We already solved the Roman 2 integer. Now we're just taking a look at the inverse one that's a little bit harder just for fun. And we solved the other one just a few minutes ago. So thanks for stopping in, Ryan. Good to see you again. Right. So if you modulo the number by 1,000, what do you get? So let me go print our number 3749 modulo by 1,000. Right, what does that output us? 749, exactly. So if you can modulo by 1,000, then do so. S plus equals to the num, no, map dot get for what value? We want to get the value so we want to get the value from the map that corresponds to, so we modulo by 1,000. That gives us 749 back, right? So we'll do num modulo 1,000, right? This is going to be remainder is equal to this. Okay. We're going to take remainder and subtract it from number, right? And then we're going to multiply that by the return of map.get for 1,000. So it'll give us 3 M's, basically. Okay. Right. Okay. So then what I'll do is I'll set this, should I do this recursively? Pass in the new number, right? Now I want 3 M's, not 3,000 M's. M represents 1,000 each. So I want 3 of them. Right? So this will give me 3,000. This will give me 3,000 M's here. So then you need to do this divided by 1,000 here, right? And then do like so. So could I set this up recursively and say for key, if number divisible by key, in, should I start from the -1 though? For the back end? I don't know. Yeah, floor division. So num minus remainder divided by 1,000. Right. So then LF num divisible by pretty much the same thing. That's what we're going to do. So LF num divisible by the next key value, 500. We're going to do remainder divisor or modulo 500. Map.get the value for 500 times that divided by 500. So in the first case, for this value, set 3749. Okay, if this, okay, that's true. So we will go ahead and do that. We'll gain a remainder of 749. We're going to do 3,749 minus remainder, so get to 3,000. Divided by 1,000 gives us 3. And we multiply that by the value of the 1,000. So what happens if we get to the case of 49, if we get to a 40? So if num is we'll continue. Right? So you continue the loop again, but we need to set number to the remainder, right? Num is equal to remainder. Right? So you have to set the num equal to the remainder to get it to register back on the loop. Or we could say okay, so this will be an elif. Now will we copy this down again and do if it's divisible by the 100 mod by 1, 1, 1. So right off the bat, if number right, if number is equal to number in our previous things, right? Only powers of 10 can be appended. Oh, there's some other edge cases. Shoot. Dang. There's some other edge cases I didn't check about. Rip. Yeah, that's a good point too. You could just do number to floored by 1,000. Right. So we'll do it. This is going to be S plus equal map get times that. S plus equal. Right. So if number is in those 4, if it ends up being a 4 or a 9, this one's tricky. Right. I guess we'll just keep it going down all the way. So 100, 50, 10. I mean, this is getting really big. Is this how it's supposed to be? Or could I use recursion? Could I say for, could I do for key value in, right? So for key value in map, could I start from the bottom, like inverse it, right? Like, could that be if I could, rather than having a bunch of if, ifs just piling up here for all of the individual sections of this thing, could I not just say for key value using my reversed map here, for key value in map, reversed? So could I make the thousands go first? I could just reverse it myself, make the thousands go first. They say for key value in map, if number modulo by the key, then do this, right? So I could do that. So let's try that. We're gonna have to, oh shoot. Let's take this, there, delete, take this, there, delete. Oh, what the heck just happened? Oh, yeah. This, there, ooh. This, there, remove that. Command C, this goes here, and this goes here. So I'll inverse the map myself, whatever. And then make it go top to bottom. And then I'll get rid of all of these except the top one. Say if the number, so I'll say while true, if, right, so while true, if number, okay, so we'll say for key value in map dot items, right? Sheesh. Right, so for key value in map dot items, if number modulo by the key, right, remainder equals number modulo by key, map on that key to get the value, the string associated with it, divided by, floored by the key, and then set the number to remainder. And then actually we'll call, so and then it'll move on to the next key. So we don't need this while true. Right. Right, exactly. Exactly, Mahan, right? It's pretty smart, huh? So we can get both here, and I can get the value. I can just get the key, the value here at that, instead of mapping, instead of getting the get, right? I can access every single one by inversing this, making go, in descending order, and then access the key value at each stage and just loop it once that way. That's a pretty cool approach, right? So then, what do we need to do? Okay, so then that will take care of that. We just reduced that line. That was really cool. We just took out like 50 lines of code into like 5 here. Nice. I feel good about that. We're getting there. Okay, so now we have some edge cases to deal with. The values does not start with a 4 or 9. Select the symbol If the value does not start with 4 or 9, select the symbol of the maximal value that can be subtracted from the input and append that symbol to the result, subtract its value, and convert the remainder to Roman numeral. If the value does start with 4 or 9, use the subtractive form representation with symbols. Oh, so this is what we were doing. Oh, if it is 4 or 9. Right. Using the dot items you can, though. Right, because that'll access each of these items one at a time. You can't index into the map, but you can iterate over a map, yes. They're indexable, not iterable. Right, you can access a key value using it, right? So I want to see if this will run just for like a simple case of 58. Will this pass a simple case? Oh. Not even using n though. Will this pass a simple case? Let's see. No, we get null. Oh. See, we get pretty close. So on 58, LV, which is 50. Oh. If it's divisible by the key, of course it's going to be divisible by 1. So if the number is less than 10, okay, so if the number is less than 10, we need to do something different. We can't check this. You know, if it's less than 5, I mean. If it's less than 5, so we'll say if number is less than 5, we're going to s plus equals to value no. Number is less than 5 plus equals to the map index for 1 times the num. Right, so this won't handle that 4 case. This won't handle the case of 4, but will handle this here. Why can't I do what, Mahan? Okay, so now we just need to handle these edge cases, basically. This was a good attempt here so far. Only powers of 10 can be appended consecutively at most 3 times. value starting with a 4 or 9, use the subtractive form. 4, 0, 21. So if you modulo the key, the current key value that you're on, you add the string value of the number floor key, 3. So where would, so the value starts with a 4, 9. Why my previous code doesn't work? Oh, because this case here, case 2, I was omitting the 333. So I had to account for, right, because if it hits 1, well, that will happen, and it'll just multiply it by 1. And so it actually won't really do anything. Right, see if I got rid of this line here. Oh, jeez. If I got rid of this line here and ran it, I would fail case 2. Oh. Cold's acting up here. Right, see, I fail case 2 here because now I'm omitting the 3 1s at the end. Right. I'm going to think about this one for a little bit, for a few days probably. It's a medium one, so we got some time. It's a harder one than we're normally used to. So I'm going to think about this one for a few days, or at least for a little bit, and then we'll come back to it here. I was not expecting to do this one. Why doesn't it work? For that case, well, because when you come down to the case of 1, right, it'll say, okay, the number is less than 4. It's in this case, it's 3, right? So the number ends up being 3. Well, it can be moduloed by 1, yes. Or I guess it wouldn't even. So you'd get a remainder of 3. And then that should be 3 here. Because then I'm flooring it by the key. So it should be 3 times the value there. Yeah, I get what you're saying. Pointer stuff. Yeah, so I'm actually not sure why this wouldn't. Right, because the number would be 3. Because 58, right? The 50 gets hit here by the L. The 8 gets hit by the 5 on V. And then we have 3 1s that happen. So the number modulo key. Oh, so you ignore the edge cases until the end and then reformat from there. So you do this, basically find like a generic long form and then you condense it into a short form. Interesting. We'll have to think about that. But yeah, I'm not sure why this actually doesn't work. Why wouldn't it work? Why is this giving me just LV? Oh, any number modulo 1 is 0. Yeah, exactly. Okay, so that's why. Because we're moduloing by 1 here, right, we need to have it be this. So we'll say less than 4, actually, right? You're going to be at 0 and false, yeah. If the key is 1, exactly. Right, you're moduloing by 1 here, by the key, 1, and yeah, exactly. Um, okay, let's come back to this one tomorrow or maybe, and we'll polish it up. Exactly. Long form and then make it short. So this is appropriately making the long form then. We have part of the problem done. Wow, look at us guys. Look at us. We have part of the problem done. So we have the long form now and we need to condense it into the short form. So XXXV is 30 5, right? So and then LV is 50 plus 9, 59. Oh, 49. 3,700 XL 49. Okay, so this is 49. So I'm doing 20 and 15. So I'm off here. Why am I off here? So what's the difference in values between these? So XX gives me 10, 10, 10, 35, and LIX gives me 49. So I'm off by 14. When you see XXXX, you replace with XL. When you see a quadruple X's, you replace with XL. So here you got a quadruple X. Oh, and you replace with an XL. And then if you get a V, well, I got a quad X here. I replaced it with an XL. Then I'm left with an IX. Okay, so this is 10, 20, 30, 40, 45. Oh, got you. And then this is XL 40, 49. So I'm only off by 5. Or 4, I mean. I'm only off by 4. Okay. I'm only off by a value of 4, which is makes sense. If you see quadruple I, so if you see quad numbers, okay, so if you see quad numbers, oh, so that's this rule here. So if you see quad of these, you have to separate it. Then you see VIV, you do IX. Well, that doesn't really fall into the trick at all of quads. That's just kind of random. Huh. Interesting. If you guys are here, leave a thumbs up on the stream. I really appreciate you guys for stopping in. Yeah. Right. So, it's interesting. Quad is 4. VIV is 9. VIV 5 plus 4 is 9. Huh. Yeah, because you said when you see quad X's, you replace with XL. When you see quad I's, you replace with IV. But then you just threw VIV in there, which is 9. You do IX, which doesn't really have any similarities between the other two. So Roman numerals are formed by appending the conversions of decimal values to the highest from the highest to the lowest, converting a decimal place value into a Roman. If the value, if the remainder, oh, the value of the number does not start with the 4 or 9, select the symbol of the maximal value that can be subtracted from the input. Append that symbol to the result, subtract its value, and convert the remainder to a Roman numeral. That's what we're doing. If it doesn't start with the 4 or 9. If it does start with the 4 or 9, so if num index 0 is 4 or 9, so if num index 0 in 4 or 9, use the subtractive form representing one symbol subtracted from the following symbols. For example, 4 is 1 less than 5. So if the number starts with a 4 or a 9, okay, so if the number starts with a 4 or 9, meaning that it's a multiple of 40 or not, like a 4 or 9, so it's like a 40 or a 90 or a 400 or a 900, you want to create a value uh, you are using use stir to replace. So if number is index 0, what do we want to do if it equals a 4 or a 9? We want to take the value itself, pull off the remainder, right? So if the number starts with the 4 or 9, then we'll do remainder equals num modulo the key, right? So that'll give us the remainder left over. So it'll be like 400 is left as the number. So we'll modulo the number. And then, so like, because it's like 400 and 900 left over with the remainder. So if we have like 949, right? 930, we'll say. 900 is left as my number. My remainder is 30. So I need to do, so if I'm at 900, I need to do 1000 minus the 100. The C and M. So if I'm at 400, I need to do the 500 minus that. So if it begins with a 4 or a 9, we want to get the remainder. The remainder will be set as the number at the very end, right? Just like before. And we continue, right? But before that, we need to do something to the number. We need to select the symbol, the maximum value can be trying to input it. If you do divided by the key, if the number is divisible by the key and the number is in, and has a first one equal to this, right? So we'll say actually here, if here, right, else there, we'll get rid of this, or we'll take this, that there, here, 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 that down, that up, get rid of this, so if the number is divisible by the key, right, then do this. If the number starts with a 4 or 9, then we're going to do something here. We need to do something here. Right? And then else we'll just do that. So that should still work for what we're currently trying to do. Except for here, right? Int object not scriptable. I can't index into a number? Can I not? What? Can I not index into an int? Dang it. I forgot about that. That don't work. Got to convert it to a stir. Okay. So we'll convert this to a stir. And we'll convert this. Right, so there we go. So we have the remainder. So we're left with like the whole number of 440, 90. So what do we want to do with that? We want to find the key right that can make that up. So if it's 400, we want to have be D and C, CD. If it's interesting, I'm gonna have to think about this a little bit. Int audit, not sure at all. I gotta stir. So I've got this first stir the int. Gosh. Num equals stir num if num index 0 in this, else we're going to go num equals int num. We're going to convert it back. And then we'll have to do it here as well. Like that, right? So here we need to do some functionality, basically. Like for finding something. All right. Let me see if that'll work at least for the, yeah, here we go. Okay, we're back where we were. We just need to solve these cases now. This one's real messed up. So we got to do something here. We got to somehow map the 4 and 9 flat values to so that's the remainder. So I'll say num is equal to int num floor key. No, I don't want to do that because gotta do it there then. But you gotta do something here with number. With the whole num 40, 90, 400, 900, etc. Right? So we got to do something here with the whole number. All right, my cold is acting up, so I'm gonna call it here, you guys. We streamed for 3 hours today, so thank you so much for joining me. It was a little bit longer of a normal one than or one that I was gonna go for today. I got caught up in the Leet code problems, which were really fun. It was super fun. I really appreciate you guys for joining me and helping me out. Thank you so much, Mahan. Appreciate you, man. Thank you so much to Ryan. Thank you so much, Don Soap, Eclipse, Bibek. Thank you so much. Victor, you guys are awesome. We're going to go ahead and we'll take a pause on that one and we'll come back and we'll try it a different time. We did the Roman to integer one though today, which was pretty fun. And so we were able to solve this one. We made two attempts. We had everything the exact same except we had a different elif condition which was failing. So we tried it again with just this new elif condition and it works. So that was really cool on that one. But I'll be back tomorrow. Around around I'll probably do an earlier stream tomorrow. I'm gonna try to do one in the morning before things get going. I'm gonna try to go out though and go on like maybe a little walk or nature walk with my dog. And but yeah, I caught a cold here and it's starting to act up right now as I've been talking. As you guys can probably tell, it's gotten worse and worse over the course of the stream as I've been talking and talking. So I'm gonna go chill out. I'll probably I might come back maybe late night tonight for a session to work on the small business manager, but I'm not sure. I do 100% want to work on it this weekend though. We need to work on it this weekend. We started yesterday with fixing up some bugs that we had, noticed here. So like this was our picture from that we had of debugging. So we have these various statistics that need to increase or decrease or do nothing, and at various points they weren't, working appropriately. So we really started to actually hone these in and fix what was going on. And so hopefully we'll be able to polish that up. And then once these bugs are fixed, the project is done pretty much. And we'll definitely work out some time tomorrow, Mahan. I've got some free time this weekend for sure. Um, Apart from just the streams and me going on a little nature walk with my dog, that's the only things I got planned. So I promise we'll be able to. I got you, Mahan. We'll work together and get some stuff done this weekend. I Yeah, I appreciate you guys for joining me. I'll let you guys know in the Discord link down below what times I'll go live this weekend. They'll probably be around maybe, you know, noon or 2 p.m. And then I'll probably take a break and then maybe come back for a normal session, or I might just do one really long one at from like 2 to 7, do like 5 hours or something, and then call it there. Or I might come in and do like a early morning, like a 9 to 11, and then come back and do like a 3 to 5 or something. It really is kind of crazy. So, oh no, Mahan, got no time. We're playing telephone. Oh, we gotcha. What test you got tomorrow? Anywho, I'll talk to you guys later. I'm pretty beat. I went back to work today. I had to get some stuff done. I actually pulled together a bulk solution of urine and serum and water together of 1,300 liters was the actually I think I only pulled together about 1,100 because I have to go up to the final mark with some QSing, but I pooled about 1,100 liters of water and urine today into this huge stainless steel tank that's all apparatus, like a big apparatus. So it did require. I had to go get that done because my urine was going to expire if I didn't get it done by the weekend. So I had to take care of it today. I had to go into work. That's why I took yesterday off because I could spare one day, but I needed to rest. I was even worse yesterday. But anyways, I'll see you guys later. Sorry for my yapping. Please join me again tomorrow. Thank you guys truly for joining me again. I really hang out. Love hanging out with you guys. No, you're all good, Mahan. I just, I like to solve some of those problems on my own, and I know you guys like to help, and it can probably be frustrating seeing me, try and try and try for an hour straight, getting the wrong answer and over again. But at the end of the day, by me trying those wrong answers over and over again and coming up with my own ways of solving the problem, like that alone really helps to develop my problem solving skills and think about different ways to solve about this. Yeah. And I know I will also learn from the solution if you guys were to help me, but I do want to give it some good due diligence, give it a good at least like 1 hour of solid trial and error before I go ahead and give it a solution, right? I know some people say give it 30 minutes, but I'm in no rush. I really think a good like an hour to dedicate to the problem before I okay now like kind of like I have a sunk cost. I'll kind of go ahead and now learn from the solution because at this point after an hour it's kind of like a sunk cost like I said. So I should probably I'd be better fit like learning from a solution rather than learning from repeated trial and error. Yeah, right. There's definitely some probably some algorithm tricks that I'm missing in terms of like two pointer approach. Um, But it can be fun to come up with things your own ways and unique ways of solving problems. But sometimes, there might only be one really streamlined solution. So we have to also keep that into account too. So yeah, right. So if I don't know the tools, I might not ever even if I don't even know the algorithm tool and I don't even have an understanding of it in the first place, I might not even be able to solve the problem in general, right? So anyway, thank you guys so much for joining me this evening. Please join the Discord link down below where you can get access to all my personal resources from books, notes, projects, everything is in the Discord. I appreciate you guys coming in, but I will go ahead and